So welcome back. So now we are going to see a very famous classic sliding window pattern question. So that is longest uniform substring after the replacement. Okay, let me explain this problem first. So suppose we are given one string s and one integer k. Okay, so what you have to do, you can replace at most k character in the string to find out the longest uniform substring. So our goal is to find the length of a longest substring where all characters are same after at most k replacement. Okay, so let me take one example. So suppose your s is one string that is suppose it is a b a double b a. Okay, and k is supposed 1. So the question is saying that you have to find out the longest uniform string after replacement of at most one character. Okay, so what should be the answer? Means you can replace any one of the character to anyone to find out the longest. So if I see in this a b a is one string, if I replace b with a, so I will get a. So this is the substring which is having the same character with at most one replacement. I have done only one replacement. Okay, so I have to give the return the output with 4, the length of this particular string. If I let me take this example, ab, so I can replace only one, at max only one. So what will be this? Suppose I am replacing this, so double a triple ab, right? So length is 3. So this is not the answer. Okay, so here, so instead of thinking which character should I replace, start thinking like that, how big can my window be such that I can fix it using this k replacement. Okay, so we need to find the longest substring that can become uniform using the most k replacement. So instead of actually replacing the character, I will think in terms of a window for any substring, and I will try to calculate how many characters needs to be replaced. Okay, so in this kind of problem, so what should be our naive approach? Let's think. So what I can do, I have given one string, I'll try to find out all the substrings of that. Okay, right? And for each substring, I am going to count the frequency of each character, right? And then I will try to find out which character is having most frequency, right? Then I will check some logic. Is replacing that character is going to give me the longest string or not? So if that replacement should happen, length of the string, difference of length of the string and the max frequency. Okay, so this will give you the replacement. So let's take example for this to understand this formula. So suppose the string was a small string I am taking just to make it understand. So double a b was one string. Okay, and we know that k equal to, suppose k equal to 2 I am taking. So in this particular example, what should happen? What the frequency of a is 3. What the frequency of b? That is 2. And length of the string is 3 to 5, right? So max frequency is 3, and replacement that I can do max is length minus max frequency, that is equal to 2. So 2 is matching with our max replacement. Okay, so I can replace this, right? So this is the naive approach. And if I replace these two elements, so a, so I have replaced b with a, and I have got the longest substring, right? So this is the idea behind this. So what is the problem in this? So first thing, finding or listing all the substring is a not easy task. It's going to take around order of n square, right? Because for each starting point you have to scan the whole array, whole string, right? And after that you have to frequency calculation that you have to do. So though it is a constant, because we are having maximum 26 characters, so for this you have to count the frequency. So this order of n square is too slow for the large input. Okay, so instead of recalculating everything, we should think, can we reuse the previous window of previous work? Yes, and we are going to use the sliding window for this. Okay, so in this also we are going to use the same concept, shrinking and expanding. So let's take one example and try to do some dry run. Suppose my string is a b a double b, is the same string that I have taken earlier, and k I am taking 1. Okay, at most one character I can replace. So for this, what I am going to have, I am going to have just like before, if you remember, left, right, this should be 0, and then again one frequency array, and then I have to need one max frequency variable. Okay, and window size. Okay, so let me start now. So for right equal to 0, so which element is coming? A, right? So frequency of A, I'm going to add 1, and at that point max frequency is 1. Okay, and window is just started, so window size is 1. So our left and right are here only, left and right both are here with first character. Okay, so whether I have to check whether this is valid or not. So if you remember, length of the window, so length of the window is 1 minus max frequency, that is also 1, is equal to 0. Yes, which is less than k, so it is valid. In case of valid, I am going to expand, remember that. Okay, so now coming to right equal to 1, so character is coming now. I mean the window is having now double character. Let me write here window, it is having double A now. So frequency of A, that will become 2, and max also got changed, max frequency is also now 2. Okay, and the window size is 2. So again, so length of the window 2 minus max frequency, that is also 2, that is equal to 0, so it is less than k, so it's a valid one. So let's expand this. Right, now coming for right equal to 2. So for the right equal to 2, and remember the max length here, I'm not written the max length, right? Max frequency, I have to find out the max length also. So now till now max length equal to 2, right? So for the right equal to 2, I am getting the new character B, so my window will become now A was already there, B is added. Okay, so now frequency of A, that is coming to 2, and frequency of B, that is coming 1. Okay, so what is the max frequency in this? That is equal to 2. 2 and 1, max is 2, and window size become now 3. So length of the window, that is 3, minus max frequency 2, that is equal to 1, which is okay, less than or equal to k. So this is still valid, right? I'm going to expand now, and here max length is, what is max length is coming to 3 now. So for right equal to 3, which is the character A, so my window will become B was already there, again A is added, right? So frequency of A, that is become now 3, and frequency of B will remain same, that is 1, right? Okay, so what is the max frequency now? Equal to 3, and window size equal to now 4, right? So again, the length of the window, that is 4, minus max frequency, that is coming 1, which is still valid in case of this, because k equal to 1, so it is equal to 1. So I'm going to expand this again. It's a very classic problem for the dynamic window protocol. Okay, so let's see. Now coming to step 5, so where right equal to 4. So in this, in right equal to 4, the element that is coming is b. So our window will become a, b. A was already there, I'm going to add b now. So frequency of a, that is equal to 3, and the same way frequency of b, that is equal to now 2. Okay, so what is the max frequency now? Is 3, and window size equal to 5, right? So now we have to calculate how much character, we have to take the decision whether you have to expand or shrink. So for that, window length is 5 minus max frequency is 3, that is coming to 2, which is less than k, is not valid, right? Because k was 1. So in this case, I am going to shrink now. Here shrinking will start. Okay. Okay, so in shrinking, you know that we have to push the left towards the right. Okay, so our left will go from 0 to 1, correct, index. So I'm going to remove the first character, that is a. So window will become now a, b, right? And now frequency will also change. Frequency of a is now 2, frequency of b is now 2, both are equal. Max frequency, what is the max frequency in this? So max frequency will remain 3, okay, because these are 2, earlier we are having 3, so this variable will continue with the same. So max frequency will be 3, we are not going to reduce, and window size is now reduced, that is equal to 4. So let's calculate again. So window size is 4 minus max frequency 3, that is coming 1. So now it is valid. Okay, so it is valid. Now I'm going to expand again. But remember, our left pointer is at, just for reminder, so left pointer is at 1, index 1, not on 0. Okay, so let's do now right equal to 5. Earlier we were doing the right equal to 4, right? So right equal to 5, now coming to right equal to 5. So the fifth character is coming as b, so our window will become, a, b, b, correct? And frequency of a will be 2, frequency of b equal to also 2, 3. Okay, so what is the max frequency now? It will be still 3, okay, because 3 was coming and they both are equally, or so 3 is there, but window size will be changed now. So window size will be 5. So now again we are going to calculate. So window size is 5 minus max frequency 3, that is equal to 2, which is less than k. No, is invalid again. So let's shrink now. Okay, so in shrinking I am going to increment the left. So left was there, so left was now 1 to 2 has moved. Earlier it was 0, then 1, then 2. So I am going to remove again the a character. So what will happen now? Window will become now b, a, b, b, and frequency of a will become now 1, and frequency of B will become 3. That is same, right? So in this case, what is happening? Max frequency will be same, that is 3, but window size is, that is 4, correct? So again I'm going to do the same operation, this one. So 4 minus max frequency 3, that is coming 1, that is less than or equal to k. This is now valid because k equal to 1, so it is valid. It's valid, so I'm going to expand again, correct? So now I'll move my right to 6. So which character is coming in the 6th position? That is also A. So window will become B A double B A, right? Okay, so this one is the window now. So let me calculate the frequency of A, that is 2. Frequency of B, that is now 1, 2, 3. Okay, so max frequency is going to be same, that is 3, but window size is changed here. Sorry, I think I lost my page. Just a minute. This one. Okay, so my max frequency is equal to 3 and window size that equal to 5, right? So again I'm doing the same operation. 5 minus 3, that is equal to 2, less than equal to k, invalid. So I'm going to shrink again. Okay, so let's shrinking now. So earlier left was at 2, now left will move to 2 to 3rd index, right? So I'm going to remove B now again from here. Okay, so this element I'm going to remove. So my window will be left with A B B A, right? And max frequency, frequency of A is 2, frequency of B, that is also equal to 2. So max frequency will remain same because 3 is already coming on, and these two frequencies are not greater than 3, so it will continue to 3. Window size has been reduced now, so window will become 4. So again I'm doing the same operation. Window size 4 minus max frequency 3, that is equal to 1, which is less than equal to k, so it is valid one. Okay, so I'm going to expand again. Okay, so if you see, I think we have come to the end of the string. We don't have any other character. So for us, the max length variable will continue to be 4. So this is window size there. So every step we are calculating the max length. So this is the answer. So this answer says that the length of that max substring where only one character can be changed to make it longest one, so that size will be 4. So only this is possible. Okay, so hope this makes sense and you have understood all these steps. So whatever observation that you have seen, what operation that you are doing, we are going to do the same in the code also. Okay, so let's see you in the next one.